Okay, so kinetic molecular theory, this is going to be short and sweet. This is stuff that we've already talked about before, but we're going to talk a little bit more in depth so that you can answer these questions like an AP student and not like a regular chemistry student. So kinetic molecular theory, these are the laws that we go over were based on certain assumptions, and that is the assumption that we get these ideal gases. So gases consist of tiny molecules which are continuous random motion. That's kind of makes sense, right? Don't really have anything to elaborate on that. 2, the distance between molecules is large compared with the size of the molecules themselves. So the volume occupied by a gas consists mostly of empty space. So what is that saying? What can we say?
A lot of it's nothing, but some of it is actual gas.
Okay, so compared to their size, the molecules are far apart compared to their size. Okay. And then gas molecules have no attraction for one another. So 2 and 3 are really talking about ideal gases. Since they're far apart, then they wouldn't be attracted to these other molecules. Whereas if they were attracted to these molecules, then they wouldn't be as far apart. They'd try to get closer to the other molecules. Gas molecules move in straight lines in all directions, colliding frequently with one another and with the walls of the container. What is this the definition of? Colliding with the walls of the container. Pressure. So this is your law or your definition of pressure. No energy is lost by a gas molecule with another gas molecule or with the walls of the container. All collisions are perfectly elastic. This is more what you'll talk about in physics, so we're kind of going to just skim over 5. And 6 says that the average kinetic energy for molecules is the same for all gases at the same temperature. And the value is directly proportional to the absolute temperature. To the absolute temperature. I would say we're going to be talking about in kelvins. Okay, so this is an equation. Kinetic energy. The average kinetic energy is equal to 3/2 RT. Now, they do not give you this equation on the reference chart. You just have got to memorize this. They do tell you that KE is equal to 1/2 mv squared. But that's for like a particle or something we would be talking about in physics. But when we're talking about in chemistry, average kinetic energy is the average for 1 mole or for a mole of a substance. So maybe they give you this, the 1/2 mv squared, to throw you off, but we really don't use that in chemistry.
So if you have like 2 moles, if you have the average energy, would you multiply that percent by 2 or something? Or do you just kind of factor out the 2?
You just factor out the 2, yep. So, so you can see that your kinetic energy is directly proportional to the temperature because this is going to be constant and this is going to be constant. So temperature your kinetic energy is based on temperature. Okay? So, and then remember that all gases are most ideal when they're at high temperatures and low pressure. So why would that be at high temperatures and low pressure? Okay, so they're making more space between them. And then at low pressure, they're not colliding. They don't have that attraction to each other. Okay? So with KMT, tell me. Oh, it's not here, is it? Okay. So we're going to ask this question. Using the postulates of the KMT, why does pressure, so I would just put this down in your notes somewhere, why does pressure increase as temperature increases? So why does pressure increase as temperature increases using the kinetic molecular theory? So what can we say?
Because as temperature increases, there's more kinetic.
Okay, stop right there. So as temperature increases, kinetic energy, or the average kinetic energy, increases. Okay, so we know that that's happening. So now tell me, how does this affect pressure?
Because since they have more energy, they collide more with each other most of the time.
Yep. So increase in kinetic energy causes an increase in collisions between molecules and the sides of the container. Therefore, pressure increases. So you must be able to take a look at that. If I ask decrease, you have to look at those things and knowing KMT, why if your kinetic energy, why does pressure decrease? And relate that back to kinetic molecular theory. Any questions on that? No? Okay, that's it.
We're just going over the slide.
Yeah, tomorrow we'll go over the rest of the slides. Tomorrow shouldn't be that long either.